would just
In
reinforce
fact,
it.
I'm going to do that today. There was a few years ago, there was a survey, and survey was, okay, can you please draw a mathematician?
Yeah,
And like 90% of the people who took the survey draw a white man with gray hair.
exactly. Exactly. And yeah, it's true.
And I'm probably going to ask the ChatGPT to draw a mathematician just to see what it will
But
do.
can AI be trained to actually do the opposite? Now it's failed many times in like Google tried to, diversify their AI and ended up upsetting all kinds of people because it made changes that were not accepted. But simple changes like having, when you look up a mathematician, Katherine Johnson comes first.
When the students see that Katherine Johnson, who was she? Women. Amy Notter, was she? Women. What did Katherine Johnson do? She put the man on the moon
Yeah.
on July 20, say 1969. What did Amy Notter do? She was the greatest mathematician. Like if you name 5 mathematicians, she would be one of them. Oh, who are they? They're women. They
Yeah.
are stereotypes now at the front.
Exactly. It's like that. There's a movie about Katherine Johnson that's
I
out
think
now.
Hidden Figure.
Yeah, and that is exactly what I'm talking about because people don't expect it, and that's how you break the stereotypes down. You show the reality of the situation by by highlighting, like you said, bringing Katherine Johnson to the fore.
I'm very interested to know, when was the first time you realized that there is a math in language?
My name is Robert Clapperton. For the last 7 years, I've been developing online education tools and online education courses. And for the last 4 years, trying to build artificially intelligent applications to put in those courses, because those courses tend to, I don't want to say be boring, but they have ended up being a little bit boring. So,
Everybody, this is Rashi from Bari Science Lab, and I have Bob over here from Toronto Metropolitan University. And let me actually introduce him. He is Dr. Robert Clapperton. He earned his PhD in English from University of Waterloo, and he is expert in language. And nobody else see math in language and computer science or AI as much as Bob does. So that's why I invited Bob, because I see math only in physics. When I drop something, I know that it's going to accelerate downward with negative 9.8 meter per second. So, but I don't see math in language. So hopefully, Bob, you want to help me see some math in language. So before we dive in, just remind everybody, this is an exciting time. Why is that? Because last month we celebrated Black History Month, and this month we are celebrating Women History Month. Did you also celebrate Black History Month back in Canada?
Yes, we do. Yeah, absolutely.
Oh, and the Women History Month this month as well, right?
Yep.
So okay, that's great. For example, when we celebrate Katherine Johnson life, we not only celebrate math, but we also celebrate the Black History Month and Women History Month at the same time. So you can accomplish a lot by celebrating, for example, someone, Katherine Johnson, in your classroom. So Bob, thank you so much for joining all the way from there. Are you right now at Toronto Metropolitan University?
No, I'm at home right now. But
Okay.
yeah,
Excellent.
thanks for inviting me.
Thank you. Now, yeah, tell us something about you before we start.
Sure. I'm an associate professor in professional communication. And as you said, computational linguistics is my area. I'm nowhere near you in terms of math knowledge and math. I have math knowledge on abstract conceptual levels, not a very good practitioner. I have a company called Amitros Learning, where we develop AI-based simulation platform for students to learn how to critically think, problem solve, face things like biases, and be able to give them a chance to have a work integrated learning kind of experience that's risk-free and scalable, so we can offer it to every student.
I see.
So
Okay, I know you develop a platform, natural language understanding experiment platform, and lots of university in North America uses your platform, but who is your audience?
Students, university students. So the way it works is Well, the kind of story about it was when I went back, I was in software before I went back to do my PhD. And when I did my PhD at the University of Waterloo, I was teaching a class in writing. And I'm standing in the front of this classroom with about 40 students sitting at desks, and I'm trying to teach them how to write, and they're writing things, but they're writing everything for me. They're not learning how to actually write for an audience, how to write for different people. So at the time, I was working with some people at University of Waterloo that were doing in the artificial intelligence lab, and started to think about, could we create a platform where students could go on and take on a fictitious role, like become a consultant or become a public servant or something, and enter into these projects with what are basically AI natural language capable characters and communicate with them to try and solve problems. So we've developed hundreds of them, from short little 1 hour long kind of interactions with a student and a character to 12-week long virtual co-ops for universities, where online universities use it as a way to give work integrated learning to students that are only available online.
So I wonder, when was the actually first time? I'm very interested to know, when was the first time you realized that there is a math in language?
I remember when I started studying linguistics, and at the time we were looking at how could we create this natural language understanding model that we could start to build the characters with. And at the time we were using basically hidden Markov models, and the idea of math where you have this language is this set that has this underlying hidden kind of connection to it, where the set that determines how the set continues. So Markov models were all about how to try and figure out if you had what was called an n-gram, or 2 or 3 words, and what would be the next word. And it was all about trying to estimate and produce. And now it's kind of done much more of Bayesian stuff, and it's done much more on using transformer neural networks. And it's been such a progression of the technology, of the math that's involved in how that prediction of the next word comes out has grown so much. And I mean, we could talk about that forever in terms of what happened with transformer neural networks and things like that.
Absolutely. Who would have thought that there is a math in language? I never did, but now I can see, I can smell some math in language. For example, as you said, that you can say in math, we always look for pattern. If I say 1, 2, 3, and then you probably going to say 4.
Yeah.
And in language, if you mention 2 or 3 words, there would be an expectation of like the next word. So there is a pattern I see. And also probably the verb adverb proposition, and that also there is some type of mathematical rules structure, just like as you said, set theory. So this is math in language. And
And then the way it evolved was they came up with something called word embedding, where they took all of language and they assigned numbers to each word, and then took all the words and put the words that were commonly used together in closer proximity. So if you had the word cat, the word purr and the word claws would be closer than the word table and chair. And it totally changed the game in natural language understanding, because it meant that before, if you had a sentence like the server brought the check, you didn't know, the language wouldn't be able to tell what that server was. Was it a computer? Was it a human being? But with language embedding, because of the word check, brought, those kind of things being closer together in that word embedding, is able to determine it's actually a person, not a computer. So that's mathematical. It's all mathematical and trying to figure out, it's called the attention algorithm, and it's all about seeing how close the words actually are linked together and using that to do the prediction. It's kind of how ChatGPT works, in my non-mathematician explanation.
So ChatGPT, that means ChatGPT uses a language model. Okay, well now let's ask you this question. ChatGPT use more math or more language?
ChatGPT is basically math.
It's basically math. But
it's basically math, but
how
the
does it
numbers
use the
referencing
language?
words. Because it's basically turned every word into a number.
Every word into a number.
Yeah, and then it's used word embedding to bring like words together, so closer in numbers in essence, kind of. So the word cat might be, like, lack of a better example, maybe cat is 001, and purr is 002, but table is 0097.
I
You know,
see.
so it's not close to the two, but the idea that then you can bring the words together. So that, I mean, I'm not doing a very good job explaining the attention algorithm, but in essence, it's kind of taking words, making them into numbers, and then bringing the words that are most likely used together closer in terms of their number value.
For example, this is like a telephone number. This is not like pi is equal to 3.14.
Yeah, exactly. It's kind of more like what language actually is. When we think about language, words only are words are completely defined by what they're not. You
I
know,
see.
the word cat is not dog, is not pig, is not
Okay.
table, is not this. So that's basically everything is about words are defined by the words that they're not. And it's the same idea. Like it's, you know, you give a reference to that number, you've now pretty much created a situation where you can identify that word by what number it is not. That makes
I
sense.
see. Even if I say number, as you said, that the table is not chair and table is not a cat.
Yeah,
Number 3 is not number 1. Number 3 is not number 4. Number 3 is number 3.
exactly.
So
But you can use the numbers to calculate now to figure out which words are closer to each other.
and that's how ChatGPT figure out.
Yeah,
Oh,
and it
what-
still uses a Bayesian algorithm to come up with a probability as to what the next word's going to be.
What
But that
the next
attention
word-
algorithm makes that so much more accurate. As you can tell when you use it, it's pretty much
Absolutely,
perfect.
absolutely. And it does faster than human brain, of course.
Yeah.
Human had to see math in language to put that in action.
Mhm.
And someone like you who did see math in language and try to put them together, take the advantage of AI and make it useful for a student around the world, especially in North America. That's really huge.
I don't know if I have a favorite mathematician. I have lots of favorite linguists, like people that have worked in language. But then I started to think about the
Who
math.
is it? Noam Chomsky, or who is your favorite?
I'm much more particular to M.A.K. Halliday, who did
Yeah.
functional grammar, and
Right.
that and Austin's speech acts. I mean, we built our original algorithms around that construction of creating of defining speech acts. And
How they are different from Noam Chomsky?
Noam Chomsky was more about looking at how language happened. You know, like so he kind of believes there's a language module in our head. Like to really simplify it, I mean, I'm not a Chomsky expert, but the idea that we have a language module in our head and
Right.
it's kind of we're predetermined to have this language ability. So Chomsky was much more about how language evolved and developed and how it happens. And again, I'm not a Chomsky expert, so there might be people out there listening saying could come up with a much better response. I'm much more on the pragmatic side of language and so things like speech acts, things like functional grammar, looking at ways that when words are put together, what do they actually accomplish and do?
That's right. So we are actually we have a chat GPT over here, but it's not as fast. It cannot process the information as fast as chat GPT, but our head is kind of a chat GPT. Is
Yeah.
the math language model to
It's as
figure
fast.
out.
Yeah, absolutely. I think we're as fast. We just can't do it. We can't access the semantics as quickly, but we can put it together quicker.
That's true. We cannot access so much information that ChatGPT can access. It's because we don't have a neural. I don't know what our brain lack. Why we cannot have access to unknown.
But we just don't have the endless, like when you think about the computations that happen in order to put a normal paragraph together in ChatGPT, they're massively long. We're
Right.
much more, our cognition is more serial, like it's more multi-layered.
Right.
It's more, I'm trying to think, that's lost the term, but it's more hierarchical and more, like we have layers of computation that happen, where ChatGPT is much more linear, mathematical.
And probably we cannot access unlearned knowledge.
Yes, we can
We have only access to the knowledge that we learn through our experience in a very hard way.
And it's in memory, yeah.
Yeah, probably. But going back to who was behind the scene, who influenced you to see math in language?
I think Markov, like the idea of, Markov's original idea, and I don't know anything about the man Markov, but his idea that sets there are Markov sets, which means it's something where the element of the set is only dependent upon itself, not, prior conditions and all that sort of thing. And then when someone took that idea and developed this idea of hidden Markov models, it allowed you to basically create a probability function where you could start to look at what would probably be the next word in the set by taking that original Markov idea and looking at, they used to be called n-grams, and they were like either bigrams, trigrams, things like little collections of words, and then probabilistically figuring out what the next probable word was. I ate some. There's a lot of possibilities, but then you would look at the next one, at a birthday party, then it would figure out it was cake. And so it was that, and it was basically using that set theory of Markov to try to figure out what the next word was. It was highly inefficient and not really and it worked okay. It worked reasonably well for language, but it was never going to be anywhere near what we are.
Absolutely. But it really started the ball rolling.
Yeah.
And it influenced many people like you to think about that direction. Why then you did become a linguistic, not a mathematician?
Well, because I'm not a mathematician. I'm much more on the language side and on the linguistic side, and looking, at how language is constructed. And I'd always worked in language more on the functional pragmatic side, and not the computational part of it came about when I started to think, we need to be able to figure out a way to create a tool that students can communicate with and learn how audiences work, learn how, if you're trying to deliver bad news and you're trying to tell someone something bad news, you need to start to learn how your own strategies work and in the face of a real audience, because we're trying to teach that in school and they're writing it for me, the professor. So it's not, they're trying to practice the theory, but they don't actually get the real stakes of what's involved in actually trying to create a communication where you're telling somebody they've lost their job or something with high stakes to it.
So when was the first time you realized that you're going to apply that in action, that make a connection between, put them together, math and language, and get something bigger? And that is a platform that you created.
Yeah, I did my dissertation thesis was called Amitros, which is the name of my company. And the dissertation thesis was the explanation of this platform and how it would work. And when I got my first position at TMU, at the time it was called Ryerson University. It changed its name to Toronto Metropolitan University. And I told them about what I was doing.
Oh, I thought you earned your PhD from Waterloo University.
I did. My first teaching job, when I got my first teaching and research job at TMU, I got the job partially because of the work I'd done in combining linguistics, education theory, and AI and math in that sense. And they gave me the opportunity to create the platform. And because it's a kind of thing that has costs to it every time it runs, we commercialized it so we could figure out a way to keep supporting. But that was 9 years ago.
There is a stereotype that the man is better at math than women. What is your take on it, actually?
It's like all stereotypes. It's something that's created by people saying it, nothing else. And that's what I'm talking about, language and action. The more something gets said, the more all of a sudden it becomes something that we cognitively accept as this truth. Aristotle came up with this idea of something called the enthymeme. It's something like, she didn't do well in math. She's a girl. That missing premise that girls are not good at math becomes cognitively much more internalized by people that start saying it and start listening to it because they had to put it together. So that idea of language that gets used like that, people start to develop these cognitive biases that they start to accept as common sense, that always gets called. And so in essence, it's nothing but communication of people talking and saying things that becomes accepted. The more you say it, you see it in your country now with your president. The more he says things, the more people start to believe it, even if it's crazy.
Yeah, I'm very sorry for the recent political unfolding, but we people forever going to be loving each other.
Absolutely.
And
Absolutely.
this is a temporary thing. I think that's not going to exist for a long time.
Yeah.
Hopefully, we're going to find
But
common
he's a
ground.
prime example of how these stereotypes get started. You know,
Yeah,
if you
absolutely.
keep
Yeah,
saying it, if you keep saying it, if you keep saying it,
keep
it
saying. And
becomes.
if you can say enough time, then people will think that is true.
Yeah,
Even
exactly.
sometimes women think, yeah, they are bad at math. And when they admit that they are bad in math, their performance go down.
Yeah, exactly.
And
Exactly.
if they protest, their performance really don't go down. So, I mean, conforming the stereotype is not a good thing.
Exactly. We
So
need to build new mental models.
right now, how can we combat that stereotype? The stereotype that the women are bad at math than men.
I think the first thing is to recognize that it's caused purely by communication, nothing else. It's not caused by any reality in the brain. It's not caused by
Or the biological, yes.
it's not, there's no biological reality to these statements that get made. And once you recognize that, then you can start combating it and start to start to basically create communication now that starts to beat that down.
I see. So, like, what would be the best way to combat it? Like, a few. There are few options. Like, people around the world uses like multicultural education, and then I don't know, student of the month, positive affirmation, and what else? And mixed debate, those kind of thing. And recently, I have been thinking after kind of reading your platform and how it can help a student around the world. I was thinking, how can I apply AI or how I can use the technology to combat against this stereotype? For example, is it possible to create a website? And a website would be kind of showcasing the contribution of the mathematician that we mentioned, like Catherine Johnson, or like women mathematician, to kind of tell a student that you can be women and you still be Catherine Johnson. You can be women and you still can be Amy Notter.
Yeah.
And there is nothing wrong with gender, and is our society that creates those stereotypes. So how can we do that? I mean, you think which way a website can be beneficial?
I think you're totally right. I think that the idea of letting young women who are thinking about going into math see themselves in other people and see successful people. But I think when I was telling you, we create simulations in the platform, right, where the students are working with characters that we created. A lot of times we look at situations and create the characters specifically to go against what the common kind of expectation would be in terms of what the student's expectation be in the situation. So, give an example. We built one that has students working on a merger and acquisition project for a bank, and one of the companies is an indigenous company, and that they could potentially buy. And we created that company to not be the stereotypes that they expected from an indigenous company, and worked with an indigenous consultant who helped us create this company to be what an indigenous company would actually be, which are people trying to, run a business and work through it. And the students started to see how their own biases would kind of come up to the front because they weren't seeing what they expected. And they weren't, so they were experiencing something that was jarring to them in a way that made them see their own bias. Especially because the indigenous company of the three companies they had to select from was the right company.
When the students see that, okay, Catherine Johnson, who was she? Women. Amy Notter, was she? Women. What did Catherine Johnson do? She put the man on the moon on July 20, say 1969. What did Amy Notter do? She was the greatest mathematician. Like if you name 5 mathematicians, she would be one of them. Oh, who are they? They are women. They are stereotypes now at the front.
Exactly. It's like that. There's a movie about Catherine Johnson that's out now.
I think Hidden Figure.
Yeah, and that is exactly what I'm talking about, because people don't expect it, and that's how you break the stereotypes down. You show the reality of the situation by highlighting, like you said, bringing Katherine Johnson to the fore, making people see and understand what she did.
And how AI can help us to improve the website to serve our purpose. And our purpose is to combat the stereotype.
The problem with AI, the problem with AI in general, not the applications like my platform, but AI will always represent society in general because it's made up of the data.
Is also going to be stereotype.
Yeah, because it's going to see. I mean, there were lots of studies done years ago where they would ask for a picture of a doctor or whatever, and they would get a man and those kind of things because that's what it would just reinforce.
In fact, I'm going to do that today. You know, there was a few years ago, there was a survey, and survey was, okay, can you please draw a mathematician?
Yeah.
And like 90% of people who took the survey draw a white man with gray hair.
Exactly. You know, and yeah, it's true.
And I'm probably going to ask the ChatGPT to draw a mathematician just to see what it will.
But can AI be trained to actually do the opposite? Now it's failed many times in like Google tried to, diversify their AI and ended up upsetting all kinds of people because it made changes that were not accepted. But simple changes like having, when you look up a mathematician, Katherine Johnson comes first. So when those kind of things. And when we create our simulations on our platform to really have the AI create characters and make the characters have positions and jobs and everything that are not what the stereotypes are. Because then students at the age of 18, 19, 20 are not being exposed to the white-haired, gray-haired mathematician.
And because 50% of them are women. And if you think women are bad in math, then what are you going to get? The society as a whole will not maximize the progress. So if everyone get equal chance, I think then the society will be able to maximize the progress, and the maximization would not be possible if 50% of us suffer from a stereotype.
I totally agree.
What would be the other way of make the website exciting?
To make the website, when you say website, do you mean the platform where the students are doing the work?
When I say website, it's like I'm thinking of creating a website like I don't know, for lack of better term, like Khan Academy type of website. But the website main purpose is to combat against the stereotype. Then a student going to have access to the website during the Women's History Month, for example.
Yeah.
Every day there would be 30 days from beginning of March to end of March. A student would be assigned to read or know or exposed to one mathematician, and that mathematician would be the women. And by end of the March, a student will be exposed to 30 mathematicians, and we would probably see whether that can make any difference in removing the stereotype.
No, I agree. I mean, the way our platform works, the way the Amitros platform works, is that all the knowledge and skill always is in a context. And that context is what gives you the ability to create situations that would battle against biases and against stereotypes. Because if you create a situation where the student is talking to a mentor, a mathematical mentor, and they want to talk about what hidden Markov models are or whatever, and they want to have that discussion with the AI mentor. The AI mentor, if the AI mentor is a woman, that sets a different kind of expectation, and it starts to break down those barriers. And especially if the students are women, they're gonna expect to talk to a man in a mathematical mentorship situation, and they're not. And you can give these AI characters backstories that how they became interested in math and how they actually, were able to overcome obstacles and everything. It would be great to do with real people, but if you want to do it at scale, AI can serve that role if you take AI and train it properly and create the right characters in our sense.
On the website, right?
Yeah, on the website, on the platform, yeah.
On the platform, okay. And do you have any other suggestion? How can, other than website, Can you think of anything creative to combat against this stereotype?
The first thing when I was thinking about that, I was thinking about that movie Hidden Figures. I mean, that's one of the first things we have to do is to
I
start
think
looking
that
to tell
movie
those
also did a
stories.
good job
Yeah.
combating against the stereotype, right?
We need to create more cultural artifacts like that, like things
That's
that
right. Because
become
this
yeah,
is not a biological issue. This is a cultural issue.
exactly.
Right.
Exactly.
Right. Right. I think that's right. The more people is stepping up for the idea that this is a completely fake, absolutely fake, and this should not exist, because not 10 people suffer from this, not 100 people suffer from this. 50% of human population suffer from this stereotype.
Yeah,
So
exactly.
this should be so obvious, but
Yes.
unfortunately we are talking about it because this is not obvious.
Yeah.
Uh,
Not obvious till you talk about it.
oh yeah, that's that's right. Well, thank you, Bob, for your insight, and it was really nice talking to you.
All right. Thank you.
And
Thanks for
hopefully
having
we
me.
can have second conversation sometime next year. We can
Yeah. See how things are going.